Alright, I'll start recording.
So yeah, I probably only need this space. So basically, what's a Petier gets like a 50 by 100 like thing to chessboard, I guess. And it's the same idea. You have a function of going from here to here, and you just have to prove this is injective but not surjective. So I guess the key idea here is so say that Petier has a combination, and that has some amount of kings in here. And let's just write bytes, whatever. So some amount of kings in here is 50 by 100. So some of these kings are 500. Some of these 500 kings are going to be on white squares, in case. So if that happens, for those kings, you split this up into two 50 by 100 blocks. So the white kings, you just slide them over as they are. So that obviously doesn't break anything. So here.
What are the sizes again? It's 50 by 50.
50 by 100.
And 100 by 100.
Yeah. So basically, he has like 500 kings in here. Yeah. So some of these kings are going to be on white squares. The white squares kings, you just translate them as is into the bottom box. So they're still going to be on white squares. And for the kings on black squares, you translate them and then you reflect them across this axis. So you'll reflect all the black squares to white squares on the other side.
Wait, is it obvious they won't touch on the border?
It's obvious because if they were to touch on the border here, they would also be touching on the border back here. Wait a minute. Hopefully this just doesn't break. So if there's some black square, maybe you need to rotate it.
No, I'm pretty sure it works.
Wait, it works?
Yeah.
So
yeah, because after you reflect it, if it touches when it's reflected, you reflect it back.
Oh yeah, true. Because it can't. Yes. So I just forgot that part. Had a massive mind blank. The argument is that if they were touching each other, like
maybe we just draw them in like touching each other.
Yes. So obviously they can't be touching each other like immediately, like orthogonally, because when you reflect back, it's just going to be the same point. You have two kings on the same point, and if it's like this. If it's like two kings like this, then yeah, when you reflect it back, it's going to be like this, which would be touching each other.
Geometry.
So you can't have. So obviously it works on outside the border, and now I just shown it works inside the border. Inside this one thick strip, this two thick strip.
Border between north and south.
It's between white and black.
Oh.
The white and this is a reflected.
I see.
Why are they equal in area? Oh, sorry.
So I guess this just works, and you can just do a random construction.
So
That's pretty good.
Yeah, the same argument except with the different construction.
But do you see how the difficulty all got concentrated into one little bit? And that little bit was just like that little bit higher than the difficulty of any of the steps in this one. You see what I'm trying to say here?
Oh, because this is way shorter, but this reflection arm is making it actually.
Yeah, like it was a concentration of big brain mode. You know, going on. So maybe you can think of that as an inter solution. Just
Never use the term big brain. If your brain is big, it does not necessarily mean that it's small.
That sounds like something a small brain.
Whoosh.
actually, I actually only started using the word big brain after hearing students say big brain. Actually, I'm turning into a 16-year-old. I don't know if that's good.
That's good. You can join us.
But then when you're 17, it's just awkward.
But yeah, hopefully this just works immediately.
Oh, it's very good. Maybe we can just spell out a construction for completeness. So
your
for people who haven't seen the previous solution,
Okay.
a self-contained solution.
So we need to prove that this is not surjective. So we just need a construction on the big board that doesn't work when it backs into the small board. And one easy way to do it is just you don't even need 500. You just put them in the reflected spots. So when you reflect, they're on the same point.
No, but they have to be on one square.
Oh yeah. Oh yeah. But oh sorry, not at the
Just make
same
them
point,
on
but
up.
adjacent
Yeah.
points. Like
Yeah.
whatever. So like just here and here, they're both white, obviously. And just make the board oriented so that these are white. Because remember, it doesn't matter if you reflect the board. So just
You mean?
Yeah.
You have to go. You have the solution for you.
It were excellent.
how it
you.
works. Hopefully, we can group solve 4 if that's possible.
Oh, yeah, let's clap this one out first. Oh, it's good with the Zoom clap symbol, huh?